In this video, we're going to talk about angular speed. Now, what we have here is it's called a lawn roller, kind of a manual device that used to kind of flatten out your ground. It's pulled by a tractor. And the radius of this lawn roller is 10 inches. Oh, here I am trying to draw with this mouse pen again, not doing too well. So our radius from the center to the edge is 10 inches. And it's a lot of times in these problems they're going to give you revolutions per second. And what we have to do is convert that revolutions per second into an angular speed. Okay, so let's talk about angular speed for a second. Angular speed, remember the omega. Angular speed is equal to the central angle divided by time. Okay, so instead of revolutions per second, what we need to do is convert to radians per second. Okay, so this is 1.2 revolutions. If you went one revolution around a circle, how many radians would you go? Well, remember, one revolutions is 2 pi. Okay, so one revolutions is 2 pi, and we know we are going around 1.2 revolutions. How long did it take us to do that? Well, it took us 1 second. Okay, so our angular speed for this problem would be 2.4 pi radians divided by time, which is just 1 second. So basically it just becomes 2.4 pi radians per second. Okay, that's considered to be our angular speed. Remember, angular speed is, think about it as kind of how fast is the angle changing. How fast is the angle changing as this roller goes around in a circle? Okay, so again, our units would be radians per second, and that's our angular velocity. Now, if we had to convert that to find the speed, now in these problems, the speed of some object like the tractor pulling this roller is really the same as the linear speed of going around the circumference of the roller. So linear speed, remember our formula, we said that B is equal to S divided by T, where S is like an arc measure. Okay, now remember when you were trying to find the arc length, we said that S was equal to the radius times the central angle. S is equal to R theta, that's another formula that you've already worked with, all over T. Okay, so our radius in this problem is 10 inches, and our central angle theta, that's our 2.4 radians that we computed in the earlier part of this problem. Again, how long does it take us? In this problem, the times, there's no conversion because everything's in 1 second. So 10 times 2.4 pi is 24 pi. If you want to put this in decimal form where it makes a little more sense to the layman, it's 75.4. And what's our units? We were dealing with inches. So inches per second. Okay, so in this case we found an angular speed. How quickly is the angle changing? And then the linear speed is basically what's the distance we're traveling around our circle, which also relates to the speed of the object that's pulling your circle. In this case, the tractor is pulling the lawn roller. So let me know if this doesn't make sense. We can go over it some more. And I think I've got a couple more problems I will send you that are a little bit harder than these, but I think for any test or quiz coming up, the level of the problems will probably be similar to these. Talk to you later.